Hi everyone, this is Anum. Me and my teammate Chandu worked on the project Insider Threat Detection dealing with feature engineering and sampling techniques. Let me first define insider threat. So, insider threats are malicious acts carried out by the organization's employees who abuse their authorized access to systems and data through carelessness or revenge. For this project, we used CMU's CERT dataset version 4.2 as it has more insider threat incidents than the others. It consists of four different events: log on, log off events, email transmissions, devices, and files. Here, as we can see, ID here refers to user ID, date is the occurrence of event, and activity is activity like log on or log off activity, and if the device is connected or disconnected. This is the previous work that is done till date in the domain of insider threat detection. So we can see that the highest accuracy attained is 94.5% when the graph convolution networks model is used. The second highest accuracy attained is 94% using random forest with randomization. So here, as we can see in the dataset, further, like there are 1,000 employees in total, amongst which only 70 people are insiders. So all the previous works lacked balancing techniques, as the data is imbalanced towards non-malicious records. So our research is to focus on these techniques as well as feature extraction and to compare our work with previous work. We also evaluated accuracy post-balancing techniques. The step 1 is feature extraction. For feature extraction, we extracted 17 different features from the .csv files provided and then aggregated these features with user ID and date. We then counted the frequency of each feature for a particular user and identified it as malicious and non-malicious based on the certain criteria defined by us. This gave us a target column that is 1 for malicious and 0 for non-malicious users. These are the 17 features which are derived by us. This gives us like the time when the user logged in, like is it between 8 to 5 or post office hours, whether the user logged in during weekday or during weekend, and if they the type of file that they transferred, and if the email that is sent by them is within the organization or outside the organization. We then proceeded to vectorization, and here we created a 3D matrix. For every user, we created a 2D matrix with all the 17 features as a rows and the number of days the user worked as a columns. We then converted it into a 2D array which yields us 9,000 features per user in the dataset. We employed these four sampling techniques to balance the target classes. They are SMOT analysis, ADASN, that stands for Adaptive Synthetic Sampling Approach, SMOT plus ENN, that is edited nearest neighbor, and SMOT plus Tomic links. Tomic links is a form of condensed nearest neighbors. We selected these models, that is logistic regression, SVC, random forest, AdaBoost, isolation forest, and CNN. The major reason why we went with this is because they offer adaptability and flexibility for imbalanced datasets. We evaluated all our models on these following metrics, those are accuracy, precision, recall, and F1 score. Coming to our experimental results, we first performed SMOT analysis on all our chosen classifiers. SMOT analysis adds synthetic data and is a form of oversampling technique. So, using this technique, we saw that logistic regression and SVC got the highest accuracy of 95%, followed by CNN, which got an accuracy of 94%. The next technique employed by us is ADASN. ADASN stands for Adaptive Synthetic Sampling. This is also an oversampling technique, just like SMOT, but this takes care of distribution density. Using ADASN, we saw that CNN attained the highest accuracy of 96%, followed by logistic regression and SVC, which have 94%. The third technique which we used is a hybridization technique, that is SMOT plus Tomic links. So SMOT here is an oversampling technique. So it can add artificial data leading to the overfitting of the model. Tomic link is an undersampling technique. In Tomic link, we choose random sample from the majority class. And if this random data's nearest neighbor is the data from the minority class, then we remove this. Therefore, we are doing undersampling. So, Tomic link is like a data cleaning technique which focuses on eliminating borderline instances that cause ambiguity. Using this technique, we got a highest accuracy of 95% for both CNN and logistic regression, followed by SVC, which got an accuracy of 92%. The last technique employed is SMART plus ENN. This is also a hybridization technique, just like the previous one. But in ENN, the nearest neighbor of each of the majority class is estimated. If these nearest neighbors are misclassified, that particular instance of the majority class then gets deleted. So this technique majorly focuses on eliminating noisy synthetic samples. And in this technique as well, we see that CNN attained the highest accuracy of 95%, followed by SVC and logistic regression, which got an accuracy of 93%. Finally, for the same dataset that we used and the model which I already showed previously, we see that our model, which is a combination of ADAS sampling technique plus convolution neural network, got an accuracy of 96%, which is highest among all the previous models. In conclusion, we tackled classes imbalancing using 4 techniques. And we also saw that ADASN combined with CNN gave us highest accuracy of 96%. There also note that CNN always attained highest accuracy in every sampling techniques followed by logistic regression and SVC. Furthermore, we would like to explore other datasets in real time and investigate deep feature synthesis in diverse domains. Thank you.